Hi friends, in my last video I have explained about the principle of polarography. In this video I am going to explain about construction and working of dropping mercury electrode, nothing but instrumentation of polarography. Okay, let's see. This is a black diagram of polarography, nothing but dropping mercury electrode. Then black diagram of polarography instrumentation. Let's see. Okay, construction. Here in this there is a dropping mercury electrode. DME, dropping mercury electrode short form is DME. In this there is a dropping mercury electrode which consists mercury reservoir. Okay, it consists mercury reservoir from which mercury drops down as small drops through capillary. Here this is the dropping mercury electrode. It consists mercury reservoir. Now this one is this green color indicating mercury. Okay, reservoir, from which mercury drops down as a small drops in the form of small drops through a capillary. This is capillary. Through this capillary, the mercury will be drops down in the form of small drops into a solution. Okay, here DME acts as a cathode and also known as indicator electrode, microelectrode, and polarizable electrode. DME, it acts as a cathode. It is also known as indicator electrode and microelectrode and polarizable electrode. Okay. Then anode consists mercury pool at the bottom of the reservoir which acts as a reference electrode. Here this at the bottom of the reservoir, here this is the black one, this is mercury pool. Mercury pool is there. It acts as an anode and it is also known as reference electrode. And its surface area is large, hence it is non-polarized. Here the surface area of this mercury pool is very large. That's why it is non-polarized. And okay, this is polarized electrode. This is non-polarized electrode, and this is polarized electrode. It is cathode and it is anode, like this. Then both the anode and cathode are connected to the battery. Here you can see. Here anode and cathode, these two are connected to the battery by the appropriate ends. You can see here. And you can find here connected to the battery. Then the height of mercury reservoir is adjusted to the set of drop time as required. The height of mercury reservoir is adjusted to the set of drop time of mercury as required. That is 1 to 5 seconds. For every 1 to 5 seconds, one drop will be come out from the mercury reservoir into the solution. Then P is the potentiometer by which we can apply potential in the form of electromotive force. Here you can find P. This is potentiometer by which we can apply potential or voltage to the solution in the form of electromotive force. By which potentiometer we can apply potential or voltage in the form of electromotive force to the solution. Then G is the galvanometer which measures the current strength. Here you can find G. This G is the galvanometer generally useful for measuring of current strength. Then this is shunt. Okay, S means shunt. Shunt is generally useful for adjusting the sensitivity of galvanometer. Okay, you can see here shunt for adjusting the sensitivity of galvanometer. Then nitrogen gas is allowed to pass through solution for removing of dissolved oxygen. Here by which way nitrogen gas is passed through the solution. For what? For removing of any dissolved oxygen present in the solution. If solution consists oxygen dissolved form, the oxygen will be removed by passing nitrogen gas into the solution. Then to the analytical solution, supporting electrolytes like KCl is added. The concentration is 50 to 100 times of the analyte concentration. Here this is the sample solution. In the sample solution, sample will be there, analyte molecules will be there. To the sample solution, we need to add supporting electrode, that is KCl. The concentration of KCl is 50 to 100 times greater than the analytical concentration. So this is the construction of dropping mercury electrode at polarography instrumentation. Here this is the dropping mercury electrode. This one, it acts as a cathode and also indicator electrode. Indicator electrode means it indicates the changes in the current. Okay, related to the concentration of the sample. Then it acts as a cathode, and at bottom of reservoir mercury pool is there. It acts as an anode. Here both cathode and anode are connected to the battery, and P is the potentiometer by which we can apply potential in the form of electromotive force to the solution, and G is the galvanometer which is useful for measuring the current strength, and shunt it is adjusting the sensitivity of galvanometer, and nitrogen gas is allowed to pass through solution for removing of dissolved oxygen, and to the analytical sample, to the analyte solution we need to add supporting electrode, that is KCl. The concentration of KCl is 50 to 100 times greater than that of analyte molecules. Okay, here this is about construction. Let's see the working. Let's see the working of polarographic instrumentation. Then DME is polarized electrode and Mercury pool is non-polarized electrode. Okay, that we know it. Here, consider polarographic cell consists cadmium chloride CdCl2 solution to which external electromotive force or potential is applied. Here you consider this is the polarographic cell. Okay, in the polarographic cell what is there? Sample solution is there and KCl is there. Here to which we need to apply potential, by which we need to apply potential and electromotive force, right? Here, what is the sample here? Consider cadmium chloride. For example, cadmium chloride is the sample solution. For the sample solution, we are applying potential or voltage in the form of electromotive force. Okay. Then what is happening next? The positively charged ions present in the solution will attract towards DME by an electromotive force, and as well as diffusion force, resulting concentration gradient formed at the surface of electrode. The positively charged ions present in the solution will attract towards DME by an electromotive force and diffusion force. Here, after applying potential in the form of electromotive force, here whatever the positive charged ions present in the solution will move towards cathode, will move towards dropping mercury electrode, surface of dropping mercury electrode, because it is having which charge? Negative charge, then positive charge will be attracted to the negative charge cathode. What are the positive charge ions? Present in the solution? And cadmium ions are there, and as well as the KCl, K+. Okay, these cadmium ions and potassium ions are there. These are moving towards the surface of the dropping mercury electrode, the positive charged ions. Then why these are moving? Due to electromotive force and as well as diffusion force. Diffusion force and as well as electromotive force. Here diffusion force and electromotive force, resulting concentrated gradient formed at the surface of electrode. Here once all the ions are moving to the surface of DME, then what will happen? Concentrated gradient will be formed. Means most of the ions are accumulated at the surface of cathode. Here more concentration at the surface of DME, more concentration is there. Here less concentration is there. This makes the concentration gradient. It leads to the current passed through the solution. Okay, the current start flowing through the solution because of concentrated gradient. Here the current start flowing through the cell. The concentrated gradient is formed due to the cadmium ions and potassium ions moving towards the surface of DME. Because of that moving, okay, what is happening? Most of the ions are accumulated at DME surface. Here less concentration at Mercury pool. It leads to concentrated gradient formed between these two, okay, electrodes. Then current start flowing through the cell. Okay. Then the applied voltage is allowed to increase with time. The current produced is recorded. As the potential voltage increases, the current, okay, as the current and potential increasing with the time, the current producing also will be increased. Okay. The current produced has to be recorded. Okay, as the potential increasing with the time, the current will be produced. That has to be recorded in the polarography. Then plot a graph between applied voltage versus current. Then we need to plot a graph between applied voltage on x-axis and current on y-axis. We have to measure current in the polarography. As the voltage increases, current will pass through the solution. Then whatever the current passes, that we have to measure. Okay, here you can get sigmoid shape curve. That is sigmoid shape curve. We already discussed in the principle. Okay, here you can see you will get this kind of curve. Here point A, B, C, D, E. A, B, C, D, E points are there. Let's see. From A to B, small current flows. This is known as residual current. and it is due to impurities and supporting electrolyte present in the sample solution. Here from point A to B, here this is small current. Here this line is due to this small current is produced from A to B. This is known as IR, denoted by IR. This R means residual, I means current. This is due to residual current. Okay, this is known as residual current. This residual current is due to impurities present in the sample solution and as well as supporting electrode, that is KCl. Okay, because of these two, this from A to B current will be produced. Here, then current increases along the curve. At point B, the potential of electrode becomes equal to the decomposition potential of the cadmium ions. Here you can see, here at point B, decomposition potential. The dotted line indicates decomposition potential. The potential of electrode will equal to the decomposition potential of cadmium ions. Means at this when current reaches when potential reaches here, this point, the cadmium ions are undergoing decomposition. The solution will undergo decomposition. Means cadmium ions are moving towards the surface of electrode. Starting here, the main sample producing current from this point only. Means decomposition potential. Okay, the electrode potential is equal to the decomposition potential of cadmium ions. Then current increases along the curve B and D. Then you can see here from B to D there is sharp increase in the current. Sharp increase in the current. Okay. Then at point D, current no longer increases linearly with the applied voltage. Means you can see here from point B to E, when current reaches point D, as the voltage increasing also, the current will not be increasing. As linearly we cannot get. Here you can get constant current. Means there is no increase in the current. Means okay, current will not be produced as the voltage increasing also. Here then, but reaches steady limiting value at point D. This current is known as limiting current. It reaches steady value, that is known as limiting current. L means okay, here L means nothing but limiting current, limiting, and I means current, limited current. Then the difference between the residual current and limiting current is known as diffusion current. Here we know now, here up to this is known as current is known as residual current. From D to E, as the voltage increasing also, there is no current produced. Here at least steady value, that is limited current. The difference between these two, limiting current and residual current, it is known as diffusion current. Means this is the diffusion current. It is mainly due to the cadmium ions present in the solution. Mainly due to this current is due to the ions. Sample are analyte ions. Okay, here because the sample, the electrode potential is equal to the decomposition potential of cadmium. Okay, at this point the current will be produced due to the sample or analyte cadmium ions. Then here you can find the C indicating the off-wave potential E off. That is we already discussed now. This is characteristic to the functional group or element present in the sample. Here this I indicating this is diffusion current. This is directly proportional to the concentration. So concentration can be measured. That is quantitative analysis. Off-wave potential is directly proportional. Off-wave potential is indicating that functional group present in the sample. So it is qualitative. Both qualitative, quantitative analysis can be done. Here, then this is about construction. This is about working of DME. Okay. Then advantages of DME. What are the advantages? The surface area is reproducible with any given capillary. The surface area of DME is reproducible with any given capillary. Constant renewal of electrode surface, eliminating the poison effects of mercury. This is second. And mercury forms amalgam with most of metals. That is third advantage. And fourth, surface area of drop time can be calculated from the weight of drops. By using weight of drops, we can calculate the surface area of drops. Okay, by using the surface area of drops, we can calculate it. Okay, the surface area of the drop can be calculated from weight of the drop. This is advantages. Then limitations of DME and some drawbacks are there. Let's see what are those. The surface area of each drop of mercury is never constant. The surface area of each drop is mercury is never constant. Then mercury is poison. So careful handling is required. And third one, only useful for analysis of reducible and oxidizable substances. that we already discussed in the principle. For electro-oxidizable reducible substance only we can analyze by polarography. On changing the applied voltage, there is a change in the surface tension and as well as drop size of mercury. So this is the construction. This is the construction and working of DME, nothing but instrumentation of polarography, and as we have seen the advantages and limitation of DME. Okay, here the question will be asked like that: what is the importance of KCl? What is the importance of nitrogen gas in the polarography? Means it is eliminating for removal of oxygen. Here, the supporting electrode which produce current is known as residual current. The impurities present in the sample will create which kind of current? Residual current. That is the thing. Okay, this is the overview of instrumentation of polarography. If you like the video, please subscribe to my channel and please share to your friends. If you have any doubts, you can ask in comment section. Thank you very much.